Here we have a rather nasty log expression or exponential expression, it's kind of both, that we need to simplify. Got to figure out how to simplify it. So I'm going to do some crazy magic trick. You're going to wonder how I did it, but I'm going to just be using these couple of rules here. So what I'm going to start with is I'm going to say, you know what, I have this 4 times ln of 2 times log base 2 of x. Here's what I'm going to do, is I'm going to say, I just want to take the ln of 2, and I want to put that as my exponent on e, for reasons you'll see in a moment. Now you might be saying, well, where does the 4 go and where does the log base 2 go? Those seem to have vanished. Nope, they're still there. They're just still as the exponent of this thing. So we have 4 log base 2 of x. And why did I do that? First things first, not just why, but also how did I do that? Anytime you have a multiplication and an exponent, you can break that up as power to a power. So I'm just using this rule here, that x to the ab is the same thing as x to the a to the power of b. Now, I chose the ln of 2 to be part of my a, and I said the rest can go and be part of b. Now, why did I do that? This is going to be where I use this rule, is that when I have b to the log base b of a, I just get a. It's almost as if the b and the log base b cancel, just giving me a. That's exactly what happens here, whether you realize it or not, because ln is log base e. You can say ln of 2 is the same thing as log base e of 2. So this ln of 2 is a log base e, and guess what's going to happen? In the same way that b and log base b cancel here, e and the ln cancel. So e and ln cancel, giving me just 2 on the inside of this parentheses. And then I have 2 to the 4 log base 2 of x. I'm very close to doing the same thing as I did in the previous part, which is that this 2 and this log base 2 will cancel, giving me just x, except for the fact that there is this 4. This pesky 4 is in the way. Well, I can move that 4 up as an exponent on the argument of my log. This is using this second rule here. In log x, you can take any coefficient of a log and move it up as an exponent on the x. So now that I've done that, this 4 kind of just goes away. Let's use a rag here and kind of just make it disappear. That 4 is now an exponent on the x, and now I can safely say 2 to the log base 2 cancels. So I now have 2 to the log base 2, those cancel, and I'm left with x to the 4th, and that is my final answer.